Good day to you all. Welcome to the 10th lecture of Magnetic Compass online lecture series. Today we'll discuss about coefficients. Let's begin. What is coefficient? All the magnetic forces which causes the deviation to change in the same manner are grouped together. Then the resulting maximum deviation caused by those forces is called a coefficient. The coefficients are the mathematical representation of the deviation caused in the compass due to the permanent and induced magnetism. So when the vessel is upright, there are basically 5 types of coefficient in the ship's compass. However, on the most ships, there will be only magnetic forces that causes coefficient B, C, and D. Right? This table will help us to understand the coefficient better. So coefficient A is due to the unsymmetrical HSI near the compass position, and for coefficient A will not have any kind of curve. Right? We'll get single straight line. We'll see that one later on. Don't worry. I'm just giving you a heads up. For coefficient B, the reason of coefficient B is P force and VSI forward or above the compass induced by jet, and it follows the sine theta curve. We have already seen that P force will always give us a sine theta curve, and VSI forward and above the compass will give a induced by jet will give us a sine theta curve. Right? For coefficient C, the reason for coefficient C is Q force and athwart shift VSI, port or starboard side of the compass, which is induced by jet. But in the normal ship, we will not get this athwart shift VSI induced by jet. Normally in the this aircraft carrier, those have this athwart shift VSI, but in the normal ship we'll have only Q force. So the reason, the causes of coefficient C is Q force, and this Q force, we know that it produces an cos theta curve. However, if there is an athwart shift VSI induced by a jet, that one will also produce a cos theta curve. Coefficient D is caused by fore and aft continuous HSI induced by H, and athwart shift continuous HSI induced by H. Right? And we all know that, we have seen in the previous slide, the forward shift continuous HSI induced by H and athwart shift continuous HSI induced by H both produces sine 2 theta curve. So the coefficient D will follow a sine 2 theta curve. Coefficient E is due to unsymmetrical HSI near the compass position, but in the normal shape, traditional shape, will not find this unsymmetrical HSI near the compass position unless it is a heavy lift vessel or aircraft carrier. Those type of vessels, they may have coefficient E. Right? And if a vessel have got coefficient E, that coefficient E will follow cos 2 theta curve. So these are the normal table, a table. I want you to draw this table in your notebook. It will help us to understand the coefficients. And I'm just giving a heads up. Eventually we'll learn all this one by one. Let's start with coefficient B. Coefficient A and E we'll learn at the end, because in the normal shape we'll not find coefficient A and E. Right? So we'll get coefficient B, C, D. So that's why we are starting with coefficient B. What is coefficient B? Coefficient B is the maximum semicircular deviation caused by ship's P force. That means a permanent magnetism, and VSI forward or above the compass position induced by jet. That VSI induced by jet, we call that as B induced or induced magnetism. Right? This coefficient B varies as sine compass course, and this coefficient B also has got two type. We have got B plus or B minus. What is B plus and B minus? We'll see that one. Right? So they are the general definition of coefficient B, and they are the category of coefficient B. Right? So coefficient, let us see coefficient BP. What is coefficient BP? Coefficient BP or B permanent is the maximum semicircular deviation caused by ship P force, and we have already seen previously that ship's BP or P force or B permanent always varies as sine compass course, and it gives us a sine theta curve. Right? And coefficient B induced is the maximum semicircular deviation which will be caused by the VSI forward or above the compass position, and it will be induced by jet. And we have already seen that in the previous slide, this coefficient B induced always varies as sine compass course. Right? So and it will give us a sine theta curve. right? So now we have got B induced and B permanent, and for B permanent we get a curve like that, right? So where we have got easterly deviation on easterly courses and westerly deviation on westerly courses, right? And for B induced we get a curve like that. That is also sin theta curve. However, in that case for B induced we have got easterly, for easterly courses we have got westerly deviation, and for westerly courses we have got easterly deviation. Now if we take that BP curve and put over B induced curve, finally we'll get a resultant curve, right? Where we'll find that most of the time that we'll have easterly deviation on easterly courses and westerly deviation on westerly courses, and that will give us a resultant coefficient B, right? And that is the resultant deviation for coefficient B, right? And if we see the animation, we'll see that the coefficient B will produce uh, the deviation in like that manner, right? We can see this animation and it will create a curve like that, right? So uh, as you have seen that this curve can be two type, either on easterly deviation on easterly courses, and this deviating force will always act towards the bow and it will give us a curve like that, right? And this type of curve or this type of shape or this type of coefficient we call them as coefficient B plus, right? So or the shape which has got this type of coefficient we call it plus B shape, right? And if a vessel gives a westerly deviation on easterly heading and deviating force acts towards the stern, that time it will create a curve like that, right? And this type of coefficient we call it as minus coefficient minus B, and the ship which has got this coefficient minus B we call that minus B ship, right? How to find this coefficient B? As maximum deviation occur in easterly and westerly heading, coefficient B could be found by taking the mean of the deviation on easterly and westerly heading. However, deviation on westerly heading name will be opposite. How to do that? We'll see in the later on and in the numericals, right? Don't worry on that, right? I'm just giving a heads up, right? And the formula for that one, deviation in any heading is equal to coefficient B multiply by sine compass course, right? Again, we'll solve this slide in the numericals, don't worry, right? Now let's head towards coefficient C. What is coefficient C? Coefficient C is the maximum semicircular deviation caused by ship's Q force and athwart ship VSI induced by jet. Here is Q force is the permanent magnetism and athwart ship VSI induced by jet. As we have told before that athwart ship VSI induced by jet you will not find in the normal shape. So most of the time you'll see that the coefficient C is due to the Q force only, and coefficient C here it is the slides I have done a mistake, so it should be coefficient C, right? It will not be coefficient B. Coefficient C varies as cos compass course, right? And C induced is not usually present as we have told before in the conventional shape. Same like coefficient B, coefficient C also has got plus C and minus C. How it look like, we'll see that one, right? And as usual, C permanent and C induced, but C induced is not present in the conventional shape, right? What is coefficient C permanent? Coefficient C permanent is the maximum semicircular deviation caused by ship's Q force, and coefficient C permanent varies as cos compass course, right? And it will give us a curve like that, and we have solved this curve in the previous classes. If you look to your note, you'll find this curve, right? And this curve is for plus Q force, right? And coefficient C permanent is the maximum semicircular deviation caused by ship's Q force, and coefficient CP varies as cos compass course, right? Right, and we have seen this curve, right? We have done this slide before. Let us see what is coefficient C induced. Coefficient C induced is the maximum semicircular deviation caused by the athwart ship VSI induced by jet. That athwart ship VSI, it can be on the port side or starboard side of the compass, but in the normal ship you will not find this C induced magnetism, and coefficient C induced varies as cos compass course, and it will give us a curve like that if it is present on the shape, right? So now if we take that C permanent curve and C induced curve, and if we take this C induced curve and put over C permanent curve, and it will finally give us a curve like that, right? And that is the resultant curve, and that resultant curve is called the coefficient C curve, right? And it is a, we can see that it is a cos curve actually, and that's how we can tell that coefficient C varies as cos compass course, right? If we see the animation, it will give us a curve like that, right? So it's a cos curve, right? And if it is another C plus or C minus, it will give another type, right? If the red to the port side and blue to the starboard side, it will give a curve like that, right? Now coefficient C plus, right? When the easterly deviation occurs in the northerly heading, that time we call it as a C plus, right? And at that time the deviating force will act towards the starboard side, right? Here you see, we can see that on the northerly heading we got easterly deviation, so that type of deviation we call it plus C, and the ship which has got this type of deviation we call it as plus C ship. Minus C will occur when westerly deviation will occur on northerly heading, right? And the deviating force will act towards the port side, right? That time we call it as minus C, and for minus C we'll have this type of curve. Here we can see that we have westerly deviation on northerly heading, right? And this type of curve we call it as minus C curve, and the ship which is having this type of curve we call it as minus C ship. How to find coefficient C? As maximum deviation occur in northerly and southerly heading, coefficient C could be found by taking the mean of the deviation on northerly and southerly heading. However, deviation on southerly heading, name will be opposite. How to do that? We'll solve it in the numerical. Don't worry, don't panic, right? Oh, I'm just giving you a heads up. And formula for that, deviation on a heading is equal to coefficient C into cos compass course. Let us see coefficient D. What is coefficient D? Coefficient D is the maximum quadrantal deviation. It is not a semicircular. Remind that coefficient D is the quadrantal deviation, whereas coefficient B and C is semicircular deviation. Coefficient D is the maximum quadrantal deviation caused by ship's fore and aft HSI and athwart ship HSI induced by H. We have already drawn this graph, and we have seen that it is this fore and aft HSI and other ship HSI gives us a sine 2 theta curve, right? So that's why this coefficient D varies as sine 2 compass course, and as usual, like other coefficient D also has got plus D and minus D. And you see, for coefficient D we don't have any permanentism, so the reason for coefficient D is fully induced magnetism, right? And coefficient D for if we have got we have previously we have seen that for deviation due to athwart ship HSI induced by H, we get this type of sine theta curve, right? And deviation due to fore and aft HSI, we get this type of sine theta curve, right? But both the curve is sine 2 theta curve. However, we'll see that because the athwart ship HSI is closer to the compass position, so that athwart ship HSI will have a greater impact, right? And the value of the athwart ship HSI on the curve will be greater. So once we take this fore and aft HSI curve and put it over athwart ship HSI curve, it will give us a resultant curve, right? Which will give us like that, and we'll see that we'll have easterly deviation on northeasterly heading, right? Northeasterly heading, and this type of curve we call it as coefficient D, right? As like other coefficient D will also have two type. One is plus D and minus D. We'll see that one. Let us see the animation for coefficient D, right? For coefficient D we'll have animation like that. You see, it is going on northeasterly heading, easterly deviation. It is actually for plus D, right? And we are getting an animation like that, and finally it is giving us a sine 2 theta curve, and if it is a minus d, it will give us a in the curve in the opposite direction, right? How it look like, we'll see in the in this slide. For plus d, easterly deviation will occur on the northeasterly or southeasterly heading, right? So we'll see that here we have got northeasterly heading, and we have got a easterly deviation. If you look to your previous note, you'll see this. We have created this um, curve already, right? And this type of curve, we call it plus d curve, and the shape is which is having this type of deviation, we call it as plus d shape. Whereas we have when the westerly deviation occur on northeasterly or southeasterly heading, we call it as minus d shape, and it will give us a curve like that. You see, westerly deviation on northeasterly and southeasterly heading, but in the conventional shape you will not get this minus d in the heavy lift shape, or maybe in the aircraft carrier. Now you'll get this minus d, but in the normal shape you will never get this minus d. So most of the time in the normal conventional shape you'll get this plus d, right? However, if you get a minus d shape, the graph will look like that. How to find the coefficient d? Again, I'm telling you, this finding of coefficient d will do in the numericals, but it is I'm just giving a heads up how to find it. As maximum deviation occur in northeasterly, southeasterly, southwesterly, or northwesterly heading, coefficient d could be found by taking the mean of the deviation on northeasterly, southeasterly, southwesterly, and northwesterly heading. However, deviation on southeasterly and northwesterly heading, name will be opposite, right? And the formula for that one is deviation in any heading is equal to coefficient d into sine 2 compass course. Don't panic about this slide, we'll do the numericals and it will be clear, right? Coefficient a, right? Again, the coefficient a is the constant deviation caused by the unsymmetrical HSI near the compass position. Suppose you have got a unsymmetrical HSI, like maybe a boom or crane near the compass position, and for that boom or crane, you'll get that it is constantly affecting our compass needle, and it will give a constant deviation in all heading, right? So this coefficient a, that's why this coefficient a does not varies, and it will cause a constant deviation in all heading. Like other coefficient a also will have plus a or minus a. If we have got constant deviation on the easterly side, we call it as a plus a shape, and we have, if we get westerly deviation in all heading, we call it as minus a shape, right? So how the coefficient look like, look to the animation. You see, you have got a unsymmetrical HSI, maybe a boom or crane near the compass position. For that one, it will be deviated, doesn't matter in which direction you are going, it will always create deviation on the same direction. Here in this case it is on the easterly direction, and it will give the constant deviation on all heading, right? How to find the coefficient a? As coefficient a will cause a constant deviation in all heading, coefficient a could be found by taking the mean of the deviation on at least 3 equidistant heading, but more easily 8, right? And coefficient e is the maximum quadrantal deviation caused by the unsymmetrical HSI near the compass position. However, in this case, this coefficient e will vary as cos to compass course, and coefficient e will not be present in the conventional shape. So except in the aircraft carrier or heavy lift ship, you will not get this coefficient e, right? Coefficient e will also have two category, plus e and minus e. Let us see how the coefficient e will give us the cos 2 compass curve. If we make the animation, it will create a animation curve like that, right? And it will give us a cos 2 compass course curve. You'll see that it is giving a deviation on northerly, easterly, southerly, and westerly heading, and all other heading it is giving us no deviation, right? So that's why we're getting a cos 2 curve, right? And coefficient e, as we know that coefficient e can be two type, plus e and minus e. That coefficient easterly deviation on northerly heading will give us a plus E coefficient, right? And the curve will look like that. And whereas the westerly deviation on northerly heading will give us a minus E coefficient, and the curve will look like that. I know that I have extended this video a bit longer, almost like 20 minutes, but the most important video for your magnetic compass. We learn magnetic compass to find out this coefficient. I hope this will help you to understand the magnetic compass better. See you in the next week in correcting the coefficient. Thank you very much.